If I have a glass rod, as I have here, and I rub it, then it gets this positive charge that we just discussed. So here is this rod, and I rub it with some silk, and it will get positively charged. What happens now to an object that I bring close to this rod? And I will start off with taking a conductor. And the reason why I choose a conductor is that conductors have a small fraction of their electrons which are not bound to atoms, but which can freely move around in the conductor. That's characteristic for a conductor, for metals. That's not the case with non-conductors. There all electrons are fixed to individual atoms. So here we have a certain fraction of electrons that can wander around. What's going to happen that the electrons want to be attracted by these positive charges. Plus and minus attract each other. And so some of these electrons which can freely move will move in this direction, and so the plus charges stay behind. This process we call induction. You get sort of a polarization, you get a charge division. It's a very small effect. Perhaps only 1 in 10 to the 13 electrons that was originally here will end up here, but that's all it takes. So we get a polarization, and we get a little bit more negative charge on the right side than we have on the left side. And so what's going to happen is, since the attraction between these two will be stronger than the repelling force between these two, because the distance is smaller, and Franklin had already noticed, the shorter the distance, the stronger the force. What will happen is that if this object is free to move, it will move towards this rod. And this is the first thing that I would like you to see. I have here a conductor, this is a balloon, helium-filled balloon, and I will rub this rod with silk, and as I approach that balloon, you will see that the balloon comes to the rod. I will then try to rub with that rod several times on that balloon. It will take a while, perhaps, because the rod itself is a very good non-conductor. It's not so easy to get charge exchange between the two, but if I do it long enough, I can certainly make that balloon positive, then they're both positive, and then they will repel each other. But first, the induction part, whereby you will see the balloon come to the glass rod. These experiments work best when it is dry in the winter. They don't work so well when it is humid. So it's a good time to teach 802 in the winter. Okay, there we go. This should be positively charged now. And the balloon wants to come to the glass. You see that very clearly? Come on, baby. Okay, so now I will try to get this balloon charged a little, so there is a change of electrons that go from the balloon to the glass. And the glass it's not a conductor itself, so it is not always so easy to get charge exchanges. Okay, let's see whether I have succeeded now in making the balloon positively charged as well as the glass rod. If that's the case, then the balloon is not going to like me. The balloon will now be repelled, and you see that very clearly. To show you now that there are indeed two different kinds of electricity, if I now rub with cat fur, by tradition we do that with cat fur, I don't know why, by tradition we use silk for the glass. So if we do this with cat fur now, then this becomes negatively charged. Remember, there were two types of electricity, and since that balloon is positively charged, now the balloon will come to me. And there it is. Now it comes to me. So you've seen for the first time now clearly that there are two different kinds of electricity. The positive charge is chosen by Franklin on the glass rod, and the negative charge on the rod.